Hi, so today in this video we're going to be talking about chapter 3.4.3, which is the remainder theorem. Now, a lot of this is dependent on you knowing synthetic division, which we have covered in the previous video. But just a reminder, synthetic division, if you had something like this, and we're dividing by x minus 2, we would have a positive 2 in this corner. We jot down that 1x cubed minus 1 plus 3, and then drop it down. 1, 2, 1, 2, 1, 2, 5. And this is your remainder right here. If you're confused on what I just did, please go watch my previous video on synthetic division. But when we're talking about the remainder theorem, it's basically saying what this is right here, this answer in this box, our remainder, is going to be the answer of like the function plugged into, the number that we're dividing by, our little number in this box, plugged into our function. So for instance, our remainder is 5 here. And we found that by what? 2, 1, 2, 1, 2, 1, 2, 5. The remainder is 5. And then what we can do to verify that that's true is we can plug in 2 for our equation. So 2 cubed minus 2 squared minus 2 plus 3. And this is going to give us 8 minus 4 minus 2, which is, 2. And then plus 3. 2 plus 3 is 5. So f of 2 is equal to 5. And that's the same as our remainder. And that's the case for when we're doing synthetic division. The remainder is going to be whatever, what the answer is, like f of whatever is in this box here. So let's continue then. This one's, we're going to set it up. Since this is positive 7, we'll do negative 7 in our box. We have a negative 2, a negative 15, a negative 4, and a positive 22. We'll drop this negative 2 down. Gives us negative 2, positive 14, which is negative 1 now, positive 7, which is 3, and then negative 21, which is 1. So our remainder is 1, and that would be your answer for that question. Then we will do it again. Now, one thing to note is this is x equals 1. It's not saying that we're dividing by x. Oh, and this one says without doing the division. I guess I just did the division, but you could have just plugged in negative 7 into x here. I think that's probably what it wanted, but it doesn't know. It doesn't see our work. So this one's saying use remainder theorem to find the value of x to the x cubed plus 17x squared minus 19x plus 13 when x equals 1. Now, I think the thing here is that since x is equal to 1, so we'll do 1 here. We don't flip the sign for this one because we aren't dividing. We're not saying x minus 1. In this case, we're saying just that x equals 1. There's a difference because when we have a division, x minus 1, we want to see whatever will turn that into 0. So it'd be x equals 1. But in this case, they're already giving us what x equals. And so we can just put in the 1. So we have 1, 17, negative 19, 13. Drop that 1 down. And then 1, 18, 18, negative 1, 12. So our remainder is 12. And you can verify that. So 1 plus 17 minus 19 plus 13, because I plugged in 1 for all of those, I get 18 minus 19, which is negative 1, plus 13 is positive 12. So that is correct. Now this one, we have our 3 of x squared plus 4x plus 19. And this one has just a bunch of things that we want to divide it by. So first, let me set up this thing, 3x squared plus 3, and then 4, and then 19. We'll have a box here, the line here. For our first thing that fills in the box is going to be negative 4. Drop this 3 down. We get 3, negative 12. That'll give us negative 8. Negative 8 times negative 4 is 32. And that will be 51. The remainder is 51, I believe, in this case. And then we can get rid of that. And now, oh, whoops. Sorry, 51. Then we can try with negative 1. So drop this down. We get 3. And then negative 3, 1, negative 1, 18. So 18 is our answer here. And then we have f of x is divided by x. This one's a little bit more tricky. I don't think you can do synthetic division with this. So instead, we'll do x plus 1. You probably could. I think that you do 0 in the box, but I'm just going to switch to long division just to be more sure. So 3x squared plus 4x plus 19. X times 3x will give us 3x squared. So 3x squared plus 3x. This is long division, and if you are confused by what I'm doing, I recommend you go check out the dividing a polynomial video. So these cross out. This turns into 1x plus 19, and then we just do plus 1, which gives us 1 plus 1, which gives us 18. Yep, 18 is our remainder for that. And then let me just verify. So what I'm going to be doing is, oh wait, I did x plus 1 for this one. I meant to just do x. Hold on. I should have caught that. Well, that was a good check. It's good to check. So we're just doing x now. So instead we're doing 3x. And that will give us 3x squared still. And these will cross out. That'll give you 0 and then plus 4x. So we'll do plus 4. And that will give us 4x. Those will cross out. And then we'll have 19. And 19 is our remainder for that one. Whoops. Yeah. Ooh, sorry, it's been a long day. And then x is, f of x is divided by x minus 3. So it'll be 3 in our box. We have our 3, our 4, and our 19. We'll do 3, 9, and then 13, and then 39, which is 40, 58. And then when it's divided by x minus 2, so we'll have positive 2 in this box. That'll give us 6, 10, 20, and then 19, 39, and 39 would be in our box right there. Yeah. And then now we're using synthetic division and the remainder theorem for this one again. So we have negative 2, and since it's already giving us an x to try, we're just going to keep what it's giving us. We aren't dividing by something. We're just we're calculating a following value with it. So we'll have negative 2 times 6 minus 4 and positive 8. Drop the 6 down. That'll give us negative 12. Add these together, they'll give you negative 16. And that will give you positive 32. And that will give you 40 for your remainder for that. And then negative 1. Negative 1, drop the 6 down, negative 6, negative 10, 10, 18, 18s for that one. 0, we'll do, whoops, keep that 6. 0 times 6 is 0, negative 4 times 0 is, and then 8. 8's our remainder for that one. And then we have f of 1, so we can do 1 here. Drop the 6 down. 6 times 1, 6, 2, 2, 10. 10 is our remainder for this one. 2, drop the 6 down still, keep the 2, keep the 6. 6 times 2 is 12. That gives us positive 8, 16, 24. Yes, 24. So 24 is our remainder for that one. Yeah, I know I went through that really quick, but really, if you understand synthetic division, that one's kind of a breeze. The only thing to keep track of when you're doing these is to make sure that the difference when you have like f of -2 or like x is equal -2 versus like x plus 2, and we're dividing by that because we want to turn that into 0. Yeah, so if you have any questions, please let me know and I'll answer as soon as possible. Have a good one.